Hi everyone, this is Naishul here for SolidTech, and in this blog video I'm going to be taking a look at the express line of tools that are available to every SolidWorks user. Now these tools are found under the Tools menu, and it starts off with DriveWorks Express. Then we have something called DFM Express, which stands for Design for Manufacture. Then we have Simulation Express and Flow Express. The DriveWorks Express tool is something that allows us to configure a product based on rules. And we're going to take a look at some examples as well. DFM is a product that allows us to do some design validation. So we can define some rules and run our product against that rule, and we'll get a result out of that as well. And Simulation Express is a tool that allows us to run a linear static analysis on our part in order to find problem areas or areas where our part can fail. And Flow Express is a utility that allows us to create an analysis of fluid flow inside a single closed cavity. Let's take a look at our first example now. First example will be for design for manufacture, and so we can analyze machine components as well as sheet metal components, amongst others. So let's take a look at an example of our machine component. Here we have a conveyor drive shaft. Now we're going to launch design for manufacture, and here it is. It's a wizard-based interface. Now we can access our settings menu directly from that button, and as you can see, we can define rules for mill and drill operations, manufacturing operations, turn with mill drill, sheet metal, and injection molding. And it's as simple as defining a few criteria here that we have. So for example, we have hole depth to diameter ratio must be less than equal to 2.75, or minimum percent of hole area inside part must be greater than equal to 75%. And if you hover over any of these, you'll get a nice description of what exactly it means. So let's see how this works. Once you have your rules defined, we're simply going to click on the run, and it now runs, and it's going to give us some results here. So in this part, we have one rule that has failed, and the remaining 9 rules have passed. So we can now see, simply clicking on it, it highlights the problem area. So the depth to diameter ratio is 7.14, whereas the maximum recommended ratio is 2.75. So basically this is telling us that based on the diameter of this hole, this depth is too deep. So we need to address that. So once we address that, we can run this again, and it will pass. So let's just modify that quickly. Okay, so we now have a shallower hole, and let's run that one more time. We now see that rules failed 0, rules passed all 10 of 10 rules passed. So a nice way of doing some design validation. Let's take a look at our next example. Again, staying in the DFM product line, we're going to look at now a sheet metal component. So again, let's go into the settings. This time we're going to look at sheet metal, and here we have some similar settings. So hole diameter thickness ratio is going to be greater than equal to 1. Simple hole part edge distance to thickness ratio must be greater than equal to 4. And once again, you get the nice tool tip, so you can hover over that and see what exactly they mean. So let's run our analysis on this part now. So it's checking the part. Now we have our failures here. So 5 of 7 rules passed, 2 of 7 rules failed. So we can take a look at each one of these. So what do we have here? The ratio of the minimum distance between the edge of a simple hole and the edge of the part to the sheet thickness is 1.3. So really what this is telling us is that it's saying that these holes are too close to the edge. So there are 4 instances of those holes, and we have each of those listed here. And the next error we have is that it's saying the recommended bend radius, the radius of this bend is 1.5 millimeter, whereas the recommended bend radius should be greater than equal to 5. So we have an issue with our bend radius. So let's just correct one of these. I'll address this issue here. So we're going to push that out a little bit deeper into the part. Now let's run our utility again. And now we have only the bend radius rule failing. So that's past the rule, and that satisfies our manufacturing criteria. Okay, let's take a look at the next example. Next, we'll take a look at DriveWorks. We can launch DriveWorks directly from the Tools menu. And we're simply going to run a model, and I've already predefined this user interface right here. I can say, give me my last used values. So my last project number was 14. The next number I'm going to use is 15. And we're going to say, give me an application for standard duty. So we have some pull-down menus here. An environment that this component is going to be used is going to be dry. The gear type we can select is maybe one of these gears from the list of manufacturers that we use. This is the belt width, and the shaft type that we're going to produce. Let's say we're going to produce a drive shaft. I'm going to click the Create button. We get our document created really quickly, and we get a nice rule or a report based on all of our rules. So we can see that all of this information was driven into the part successfully. So here we have our drive shaft. Let's take a look at another example. Again, we'll run this again. So I'm just going to say last use values. This time we're going to bump the project number to 16, and this time let's go maybe heavy duty application. This time we'll have a wet application as well, or the wet environment. So when the environment is wet, we may wish to switch to a stainless, maybe a stainless steel motor or gear. And let's switch the belt to say 400, and maybe we want an idle shaft this time. So we'll create that. And here you can see we now have our idle shaft. The heavy duty application has given it a larger square cross-section area. And we've also driven in some custom value information, for example, material. Now this is simply just a custom property. It's not actually driving the material, but it's simply driven the material custom property information into this document. So that's a little bit about DriveWorks. Let's take a look at the next example. The next example we're going to take a look at is FlowSim Express. Now here I have a sample power supply, and it's got a fan inlet in this area here, and another outlet exposed to the environment. So we launch our Flow Express via the Tools menu. And I've already predefined the analysis here, so I'll just go back into this parameters just to show you. We have the ability to analyze water or air, and we can define the flow based on inlet pressure, volume flow rate, or mass flow rate. Here I've defined it based on pressure with a value of 102 kilopascals. And the outlet is basically this area here, and it's simply exposed to the environment, so we just have environment pressure. And it's basically a wizard-based interface, so we're pretty much done defining our parameters, and we're going to go ahead and run the analysis now. And so here it is, the analysis is done. We get a nice little legend here based on the trajectories and the velocity. And we also see a graphical interface here, so I can animate this. So here we see the fan blowing air, and of course this is in the green region here. So the trajectories are slightly faster, and as it gets closer and closer to the outlet, the flow slows down. So we can use this technique to analyze whether our component cooling in our design is adequate or not. I'll just have to stop this animation here, and then we have the ability to generate a report. So the report is generated in a Word document, and you get all of your parameters the model that we're running, the environment input information, and the result information. And at the end of that is a nice image, including the legend. So that's FlowExpress. Close this. And the next one is Simulation Express. And as I mentioned, Simulation Express is a tool that allows us to run a linear static analysis in order to find failure points in our model. Now again, I have run this ahead of time, so let's just go and take a look at some of the input here. So I've defined the fixtures. So the fixtures in my model are these holes here and also at the bottom. And we've also defined the loading criteria, and my loading criteria are applied to these standoffs, and it's 90 pounds. So we might have some transformers or some really heavy transformers in this box. And we're just going to, once we're done defining our fixtures and loading criteria, we can simply run this analysis and it'll mesh. It'll just take a couple of seconds to mesh this. And we get, once it's all done, we get a nice animation. Now obviously this is a highly exaggerated scale. This deformation would not be a real one-to-one scale. So we can stop this animation, and really the thing that we're interested in here is the stress plot. So we can see that our selected material has a yield strength of just under 30,000 psi, and our maximum in this model is 16,000, and our minimum is 8. So we can see that our model is certainly adequate for the design criteria here. We can also look at the results based on a factor of safety plot as well. So at a factor of safety of 1, we can see our entire model is in the blue region, which is which means it's adequate, and I can push the factor of safety up to 2, and we can still see even at factor of safety of 2, everything is blue, which is again is good. And as soon as I start approaching a factor of safety of 3, we begin to see some red areas in our model. So we have adequately designed this and also included a little bit of a buffer in our design to ensure that our part will not fail out in the field. So that's a little bit on the Express tools in SolidWorks. Again, it's available in every license of SolidWorks, and there are limitations. Now these are really just introductory tools into the full-blown part, and if you find that you do need more features available, or if you do need more features, don't hesitate to contact your local SolidTech reseller to find out more about these tools. Thank you.